Hello and welcome to my class. I'm Grolin Annalisi from ThinkMo Education. I'm currently a Cisco Technology lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. What's a PP account is? +6 5834444290. Today's topic is STP, DHCP, CDP, and ACL. In the last class, we said something about part of STP. Let's do a review first. We said it before. In the network, if all devices use a single device, then the single line is connected to another device. You will find it creates a single point of failure problem, whether it is a line or a device. We cannot allow nodes in the network to have a single point of failure, especially the core nodes of the core equipment. So we often have to analyze the entire network topology. There are some redundant devices and lines present. Then once a redundant line or device is generated, may cause loop problems. So we need to be in the second layer network environment to run protocols like STP. Let it help us break the loop in the network. Please pay attention. We talked about TTL before. In fact, TTL is a means to prevent loops. But it can't break. STP can break the network loop. Run a protocol like this. There are no loops in the network. This is the basic role and characteristics of the STP protocol. So what kind of method does it use to break the loop? It is a vertical structure, starting from a tree root and spreading branches upwards. Then it walks up to a certain device. Is there not going to be a single line plugged back into the original first device? This is not going to happen. It is acyclic. The way it passes is block some ports in the entire network. Keep them logically blocked. Do not forward user traffic. Then it can lead to no way to generate this loop. Or in other words, it is eliminated after it is generated. And if something goes wrong in the future network, for example, maybe a line is broken, I can make another interface open automatically. Complete the normal forwarding. So the agreement itself is pretty good. Today, we will formally talk about the specific content of this agreement. We talked about BPDU in the last class. In the STP of our NA stage study, there are two types of BPDU messages. A configuration BPDU. What is written in the PPT now is to configure the BPDU. The message contains these parameters. There is another type of BPDU called TCN BPDU. Let's talk about configuring BPDU first. For the NA stage, STP actually involves little experimentation, because it learns its forwarding mechanism by default. So we are in the process of lecturing today. There will be more parameters to compare. So it might sound a little difficult to understand. Let's first talk about the parameters mentioned in the previous lesson. BPDU is called Bridge Protocol Data Unit. That is a message when all information in STP is interacting. This is the message form of their interaction. In the future, we are going to conduct some role elections. For example, I want to elect a root bridge, root port, specified port. You can see it here. They will compare the messages sent to each other. Let's look at this sentence. In the future, we will conduct role elections. Never mind what you choose. When we are doing role election, will depend on the path cost, peer bid, peer PID, local PID. Here are the parameters we compare today. These parameters are covered in this message. So after they send messages to each other, to determine the respective device and port status. That is, devices are updated through BPDU messages. This is part of what we talked about last class. In the last class, we first talked about RID. It's called the root ID. That is, root bridge ID. In this field, it is always filled with the ID of the root bridge. I will simply draw a picture here to explain. Let's take 3 devices as an example. This is 3 switches. They are sending messages to each other. The sent message looks like this. It's all here. Then in this message, this root ID is always the root bridge ID. For example, this is device A. This is device B. This is device C. Assume that device A is used as the root. Messages exchanged by all devices in the future. This is all A. Equivalent to. In order to ensure the stability of the topology as a whole, the root bridge will periodically send packets downward. Other devices will forward these messages. Then while they forward, we'll tell all devices that the current root is A, in order to ensure the stability of the topology. So this field is always filled with the root ID. There is a bridge ID behind. It is always filled here. The ID of the device that sent this message. I give a simple example. For example, now the first message is sent by device A. Then the field in the message it sends will be A. Then this field is also A. One means that device A now thinks that the root bridge in the entire environment is A. Another representative is that the device sending this message is A. When this packet arrives at device C, if there are devices below, if it wants to forward down, the root ID in device C is A. But here it will be changed to C. That is, it forwarded the message. Then it needs to change the bridge ID of the sending message to itself. Bid means that it will populate the device's own bid. Look down and there is a PID. It's simple. PID refers to a parameter in the interface, where the device is currently sending this message. The PID is calculated and generated by the priority of the interface plus the port number. So this PID is generated by the STP protocol. Don't worry about this. We're waiting while we do parameter comparisons. I will tell you about this PID again. Let's go back and talk about this root path cost. We didn't finish talking about this in the last class. Let's explain it next. For the current device, I will fill in the current distance of this device from the root bridge. That is, the distance between the device and the root switch. Then we're going to have a character election right now. First we will elect a root. A tree root selected by STP is actually a device. We call it root bridge, also called root switch. There is no distance between the root bridge and oneself in packets originating from the root bridge. Now overall this parameter is 0. There is no distance from this device to the root, because the root is itself. For example, now this is still a device like this. I'm connecting them now. It now sends out a message. Then the original RPC message is actually 0. When we calculate RPC, only the cost of the receiving port will be calculated. For example, the receiving port is now 1. Then when it receives the message, when it goes down, the RPC in this message will become 1. Then received by this interface, and then it sends down. We'll accumulate the RPC of this interface again. Further down, send out is 2. Then it is received by the next interface. This should have been mentioned when I talked about routing protocols before, such as calculating cost. We call the outgoing direction of the packet. If you send it here, it is this interface, or called the inbound direction of route convergence. Routing is reverse convergence like this. Then this is the incoming interface. Therefore, The message always has a direction, including that every time we calculate the cost, there is a direction along the way. This message passes through these interfaces. But for us, we will only count received ports. It is a cumulative value.